So hi everyone, in this video I'm going to explain the CUDA program which adds two matrices on the GPU. So I'll explain the each part of this code and how it's working. So when we look at in the first cell, mm, where we have included a code where this NVIDIA NVCC code will be retrieved from the Jupyter file, so we can access the CUDA code where we are using the C programming. Basically, the collab will run in the Python or some other languages. It won't access the C language. Mostly for CUDA, we are just using the C programming, so we need to access it. So we are just using this. So first, we are just initializing the needed header files for this program. So it will just started by the C programming. So how the CUDA header files, what are the CUDA files is just needed. It will just we are just defining it. Then when we are going to this down, so we can have this check and some check called check kublas, and these check functions are called as the macros. So what is macros? Why we are just doing here? Why we have to do this? Because macros will check for the errors after the calling the CUDA functions. So if something goes wrong, like if any we have to print any something error messages to stop the program, we are just using this. These are all the needed things to check, and we can do this properly. If we do this properly, our program will execute properly. So we have each and every set of things to check like everything is working properly in this GPU or CPU. So next we are just moving to the initial data. So why this initial data? This function will just fill the matrix with the random numbers. We are not just giving the input. The computer is just sorry. The computer is filling the random numbers itself. It's generating the numbers. So this function specially just the numbers from randomly and just filled up in the arrays of matrices, and we are just giving an input to the GPU or CPU. So based on that, it just prepares the data and it will add the two matrices. So this is the main code where we are just using. Then this is the main thing where we are going to add. So we are just getting a three variables. Why we are just getting a three variables in the two, especially in float? Because these are the three things that we are getting in the pointers where we are going to add the matrices to store a thing, because in sometimes matrix can be getted sometimes like some float value. So to avoid that, to get any sort of error messages, we're just taking it. So I'm sorry. So this function mostly will get up only to the addition of matrices. So when we get two matrices, it will just add it. So we have a nested loop here. This nested loop only will just make a matrices. For IY is for one matrices, IX is for another one matrices. So we are storing the IY and IX in IC. So everything is will be working based upon the loops. So the matrix or the arrays, the matrices is a form of a 2D array. So it will just add up according to that, and we are just returning it. So we are just checking how it is going. So when we are moving to the now, so this is for a CPU. Mainly this will work under CPU, and when we moving down, so we have this part, this global part for GPU. So this is the main thing where we are going to do. So we have a float matrix A, matrix B, matrix C to store the two A and B matrices. So here we have unsigned int. So why we are just giving unsigned int? So why we are giving unsigned? It's because of the, like, we are not assigning it properly. So we have to in, we, mainly we have the thread index and block index. So because of this, we are just moving to the unsigned it because we don't know how much it's going to be the values. So we are just giving like this, and we are just adding the matrices. In above code, we are just use the nested loop. Here we are not taking that, we are just having a matrix, so directly we are just going to add it because of the GPUs how we are going to do. So next, when we are moving to down, these are all the setup functions where we are just going. So when we move to the main function, here we can see a thing called kernel. Wait, let me show. So this part is a kernel where this is the main thing for our function to add, sorry, our matrix to get added. So with the help of this only, our block index, our thread index, and based on that only, we are just moving to, we are just going to get the addition functions. According to the grids and blocks only, we are just needed to add. Based upon that only, our GPU will respond. So we need to store this. So we have a memory allocation for this host memory. So the CUDA will allocate a separate memory for matrix A, matrix B. After that, for the GPU reference where they were getting the output. So we are just getting it. So finally, after doing this, after the getting all this thing, we are just synchronizing it. After synchronizing it, we are just checking whether the kernel has any errors or not. After that, we are just for a take a time. So how many time, for how many seconds or how many time it's just going to run. So we are just checking. So first initialization, the starting initialization, we have up around 0.6 something seconds. Then for some matrix on host, the host is called the CPU. In the CPU, how many time it have taken, and on the GPU, how many seconds you have taken, based upon the blocks and grids. So this is the thing where we are just getting added. In the CPU, when we are adding, it just taking 0.05 seconds, which is bit higher time. When we're just adding on a GPU, see, it gets 0.0, so it's getting very low time. So this is the thing that I have to look upon with it.